Okay, so on Thursday and Friday, we talked about rational functions that had horizontal and vertical asymptotes. And now we're going to talk about oblique asymptotes or slant asymptotes. And there's a picture right here. So this is what it means to be a slant asymptote. And this happens when the degree of P of x, is exactly one more than the degree of Q of x. And then if that happens, then we will have an oblique asymptote or slant asymptote. And so again, our quotient is going to be P of x over Q of x. So basically, our numerator has to be a greater degree than our denominator by 1. And then we will end up with a linear asymptote. And it's going to be in the form of y equals mx plus b. Right? And the way we find this is we've done this before. We're going to use long division. So if you look at number 1, I have x squared minus x minus 14 divided by x plus 4. So we're going to be using long division. And so it's going to be x plus 4 divided into x squared minus x minus 14. Right? So I have x squared. I want to try to cancel that out. So I'm going to divide x squared by my leading term of the divisor, which is x. So x squared divided by x is x. All right? And then I have to multiply the x by my divisor, which is x plus 4. So I have to distribute this x. So x times x is x squared. X times 4 is 4x. So this is what's going to be coming down here. X squared plus 4x. And I have to subtract all of that. So x squared minus x squared would give me 0. Negative x minus 4x would be negative 5x. And then I bring down my negative 14. All right, and so my next step is try to cancel out that negative 5x. So I'm going to divide that by my leading term, which is x. X over x simplifies to 1. So I'm left with negative 5. And so negative 5 is what I'm going to multiply my divisor by. I have to do negative 5 times x, which is negative 5x. And then negative 5 times 4 is negative 20. That's going to be here. Negative 5x minus 20. So negative 5x minus negative 5x, that cancels out to 0, right? Because these two become a positive. And then negative 14 minus negative 20. Again, these two negatives become a positive. So 20 minus 14 would give me 6. So now I'm going to, this is my remainder. I'm going to ignore the remainder. And whatever is left is what the equation of my slant asymptote is. So the equation of my slant asymptote is x minus 5. Y equals x minus 5. So I'm ignoring that remainder, the 6 divided by x plus 4. So let's see what this looks like in the graph. So if I have a function f of x equals x squared minus x minus 14 divided by x plus 4. Right, so that's the graph right there. I can zoom out a little bit. Okay, and so the equation of my slant asymptote is going to be y equals x minus 5. Right. So if I go back, you can see that it's approaching my asymptote, right? So now we don't, this one doesn't have a horizontal asymptote, it now has a diagonal. And so we use y equals mx plus b to write the equation of that asymptote. And we just do that by doing long division. Okay? Try number two out. Try number two. So you're doing long division and you're ignoring that remainder. Okay, so I have 3x squared minus 7x divided by x minus 3. So you're doing, and so I am missing a constant term, so you have to add that in there. Right? So 3x squared divided by x would give me 3x, and that's what I'm going to multiply by my divisor. So it's going to be 3x squared minus 9x. So 3x squared minus 3x squared would be 0. Negative 7 minus negative 9, so this becomes a positive 9. So 9 minus 7 would be 2x. Bring down that 0. And then 2x divided by x would leave me 2, because this simplifies to 1. And then I multiply that by my divisor and get 2x minus 6. 2x minus 2x would be 0, and then 0 minus negative 6 is positive 6. But I don't care about my remainder. The only thing I care about is that my equation of the slant asymptote is 3x plus 2. Okay, does that make sense? Any questions about that? All right, so let's put it together with what we did on Thursday and Friday on the back. So on the back, I'm trying to figure out all my key features. All right, so my x-intercepts, I'm not going to worry about the domain and range today. I'm just going to worry about the x-intercepts, y-intercepts, vertical and horizontal asymptotes, my oblique asymptote or slant asymptote, and then the holes. So remember, the first step is to make sure everything is factored out. So I have to factor the x squared minus 9. So using my difference of squares, right? I take the square root of the first and second term. The square root of x squared is x. Square, and the square root of 9 is 3. And it's all divided by x. So do I have any common factors? No, so what does that mean? There's going to be no holes, right? So there's no holes on the graph. Okay, so the holes only happen when I have common factors. So now I can check for all my other stuff. So the first thing I want to check is for my x-intercept. And that is when I set the numerator equal to 0, right? So I have x plus 3 and x minus 3 equals 0. And because of the 0 product property, now I can set both of them equal to 0. And x minus 3 equals 0. So I end up with negative 3 and 3 are my y-intercept. Right? My x-intercept is negative 3, 0, and 3, 0. Next up is my y-intercept. And so that's when I have to plug in 0 for x. So I have to find f of 0. So f of x is x squared minus 9 quantity divided by x. So I have 0 squared minus 9 divided by 0. And what's negative 9 divided by 0? Oh, it's undefined, right? We do not divide by 0. So if this is undefined, what does that mean? There's no y-intercept. Good. So there's no y-intercept. So be careful with that, the dividing by 0 part. All right, so next my vertical asymptote, and that's when I set the denominator equal to 0. So x is equal to 0, and it's already solved. So my equation of the vertical asymptote is x equals 0. All right. Now next is my horizontal asymptote. So the horizontal asymptote, I have those 3 rules, right? If P is greater than Q, then there's no horizontal asymptote. If the degree of Q is greater than the degree of P, then it's 0. And if they're the same, then you use the quotient of the leading coefficients. Which case do I have here? The first one, second one, or third one? The first one, right? So the degree of P is greater than the degree of Q, therefore there is no horizontal asymptote. Alright. And now for the slant asymptote, the degree of P has to be one more than the degree of Q. So right now my degree of P is 2, right? And down here the degree of Q is 1. So 2 is 1 more than 1. So therefore I can use long division in order to figure out what my the equation of my slant asymptote is. So I have to do x divided into x squared plus 0x, don't forget about that middle term, and then minus 9. I have x squared divided by x, which is just x. So x times x is x squared. And I subtract that, I get 0, so now I just have to bring down the 0x. And so now I have 0x divided by x. I'm left with 0. So 0 times x is 0x. And my negative 9 is going to be my remainder. So I don't care about the remainder. The only thing I care about is this right here. So the equation of my slant asymptote is going to be y equals x. Okay, so let's graph this to see what it looks like. What is it, x? Okay, and then the equation of the slant asymptote is y equals x. So if you look there, that's exactly what's happening here. And I could even graph my vertical asymptote, which is x equals 0. Right. So again, these are exactly what the graph's approaching, and even on the vertical asymptote, now you can actually see what that looks like, right? And then my x-intercepts are -3 and 3. And obviously there's no y-intercept because I have a vertical asymptote there. Okay, make sense? Try number 2. Okay, so the first step is to factor this out, right? So I have 2x squared and -20. So don't forget, you have a coefficient, so you have to multiply down diagonally. So 2 times -20 would be -40. So I need 2 factors of -40 that add up to -3. Did anybody figure it out?
85.
What is it?
85. Yeah, 85.
8 and 5, so -8 and +5?
Yeah.
Right? So then I have -8x and 5x. So then, on the outside, 2x squared would be x times 2x, right? I need to put the 2x on the side because like 2 doesn't go into 5 to give me a whole number. So 8x, -8x divided by 2x would be +4, or -4, my bad. So this is x minus 4, and then this would be +5. So this factors out to be x minus 4 times 2x plus 5 over x plus 1. Okay, so now I need to find my well, first, there's no common factors, right? So that means there's no holes in the graph. So next, I need to figure out my x-intercept. And so that's when x minus 4 is equal to 0, and 2x plus 5 is equal to 0. So here you end up with x equals 4, and here you end up with negative 5 halves, or negative 5 over 2. So my x-intercept are 4, 0, and negative 5 over 2, 0. The next is figuring out my y-intercept. So f of 0, so 2 times 0 squared minus 3 times 0 minus 20, all divided by 0 plus 1. So 0 minus 0 minus 20 is negative 20, and then 0 plus 1 is 1. So my y-intercept is negative 20. So 0, comma, negative 20. Next up is my vertical asymptote, and so that's when the denominator is equal to 0. So x plus 1 equals 0. If I solve for x, I get x equals negative 1. And again, for the horizontal asymptote, here my degree of p is greater than the degree of q. Therefore, there is no horizontal asymptote. And so now this is the extra step that I'm adding. Since p is greater, the degree of p is greater than the degree of q by 1, then I can use long division in order to figure out what the slant asymptote is. X plus 1 divided into 2x squared minus 3x minus 20. So 2x squared divided by x would leave me 2x. 2x times x is 2x squared. 2x times 1 is 2x. I'm going to subtract all of that. 2x squared minus 2x squared is 0. Then negative 3x minus 2x would be negative 5x. And then I bring down that negative 20. And I have to do negative 5x divided by x. So that leaves me negative 5. Negative 5 times x is negative 5x. Negative 5 times 1, negative 5. Here I end up with 0, which is what I want. Negative 20 plus 5 is negative 15. So the equation of my slant asymptote is y equals 2x minus 5. All right. So if I graph this, of x equals fraction is 2 divided by x plus 1. And then the equation of my slant asymptote is y equals 2x minus 5. And then x equals negative 1 is my vertical. So as you can see, it's approaching that slant asymptote, and then it's also approaching my vertical asymptote at x equals negative 1. And then also my y-intercepts are for negative 2.5, which is negative 5 halves. Okay? Are there any questions about this? So we're just adding that extra step of the slant asymptote. And again, this only happens when it's greater, the degree of p is greater than the degree of q by 1. So if I had 2x cubed on top and then x on bottom, then that wouldn't work, right? Because the difference is 2. The difference of the degree is 2. Okay, any questions?